The CECE program was initiated as a result of a BAA from NASA to develop a throttling engine.
They were going to need to go back and revisit getting high-performance engines in deep space and for terrestrial landings.
NASA realized if we're going to have a chance to succeed with this, we better start with something that has already got a good amount of that capability under its belt.
There was an opportunity there to build on history.
To prove out the viability of a cryogenic throttling engine.
To demonstrate that we could create a LOX hydrogen engine to throttle down and perform the descent mission for lunar landing.
Each one of the CECE tests, labeled demo tests, built upon themselves and achieved higher and higher objectives that ultimately culminated in the success that we've had in this program.
Yeah, the program was broken up and essentially turned out to be 4 phases, although there was not much of a guarantee past the first one.
The original goal for Demo 1 was to demonstrate 10-to-1 throttling with the RL-10 derivative engine, and that was accomplished.
And that was the basis upon which the team would even get to continue to work beyond that first phase of the program.
So on Demo 1.5, we had an opportunity to basically take the same engine configuration out to test and go explore and map out some of the physical phenomena in more detail.
Through exploring all those boundaries during Demo 1.5, we found out that there were some limits to what we could do.
We still had not successfully met the objective of getting down to 10-to-1 throttling with absolutely stable operation.
Demo 1.6 went on to then institute fixes for those stability concerns.
Well, really what we're talking about is chug.
The primary goal of 1.6 was to show that we understood the physics, we could address it.
NASA was absolutely ecstatic about the results of that test. We expanded the range of operations significantly, and at that point we'd already now accumulated over 5,000 seconds of operation over 27 hot fires.
And that being accomplished, Demo 1.7 really departed into kind of new areas.
Now we could go fully try to map some of the technologies and information that you would need to design such a system in space.
We tried to expand the operability of the engine.
And we honed our skills at controlling the engine.
We demonstrated other very important things like closed-loop control. We demonstrated smooth starting to 10% power. We demonstrated rapid restarts. These are all critical elements that a lunar descent or a lunar exploration mission, or for that matter, other planetary surface exploration would require. And it was a fantastic achievement.
Everything we do here is a challenge. And the interesting part was that this was going to actually help put man back on the moon.
Being a part of this program was a fantastic privilege to me. It was definitely the kind of things that get you excited to be a part of what was going to be hopefully a return back to lunar exploration.
When it first started, the Demo 1, I built like the fuel pump or help, and I balanced the pump, assembled the turbo pump. We assembled the turbo pump onto the engine, and then assembled the engine.
I really felt great being a part of the CECE program, being able to be part of what the program set out to accomplish.
Towards the end of this last block of testing, we were in a data review and we were presenting data from the run that we'd done the night before, and we'd met the test objectives and done what we had planned to do, and one of the objectives was a very low power start. And it worked fine, and we had expected it to. And after we presented that bit of data, the customer was on the phone and they said, we didn't think you guys could do that. It's very interesting the way that worked out. We didn't think you could execute that. So it was kind of the program reaching all the way to its limits.
This is what engineers get into engineering for.
Engineering asked, and we delivered.
I think the most exciting thing is when it went to test that it ran really well, because I balanced it, and it's very important that the engine runs well. So I was happy to see that.
I came on the CECE program as a test engineer during Demo 1.5 and assumed the chief engineer role for Demo 1.6 and Demo 1.7. So the biggest challenge I had was I was coming into a very high functioning team. And as coming in as the new guy in the leadership role, I had to keep the team functioning at a high level, or actually find a way to not screw that up.
In every single program accomplishment, and any program that's out there, lots of times, you always hear about the engineering, but everybody knows this, and we always talk about it. It is a team-wide effort. It's so critically important that the broad range of disciplines that we have within the company are brought to bear to make a program a success. You need the engineering to be able to obviously get the technical job done, but you need all the other skills that support the engineering. Beyond design, you need to have the manufacturing capability to actually go create the product. You need the assembly capability that successfully puts this engine system together so it can go do what it's designed to go do. And then ultimately, you need the test capability to prove out that all of what's been designed and assembled now can go deliver the thrust and deliver the capability that the rocket vehicle needs. Surrounding that core group of engineering and operations that makes it happen, you need finance, quality, program management, procurement, legal. You need all of the other disciplines that play such a critically important role that help make a program hum along and be able to make it seem like it's effortless. And we've just had an outstanding team that's made that happen across all the disciplines.